Okay, so if we go back to a couple of days ago, we had worksheet 5.2 part A, and we know how to do long division. We did long division on this section, but we didn't do long division on all sections, right? I mean, if we take a look at a question like number 2, you don't have a binomial down here. So the best thing to do is to take this monomial and split it to each and every term and cancel things out. There is going to be a couple of these on tomorrow's test. So like on number 2, if you had 6k2m minus 12k to the third m squared plus 9m to the third. And if I put that 2k m squared underneath all of them, 2k m squared, 2k m squared, I could just cancel things out. Like the 6 and the 2 cancels out. You have a 3 left over up on top. The bottom k cancels out with one of the top k's, and you'll have one top k left over. 1m on top cancels with one of the bottoms. You have one left over. So the first term would be 3k over m. That's the first part of your answer. So this is pretty easy, right, guys? You don't need long division. This is easier than long division. You're just canceling things out. So the 12 and the 2 cancels out. There's a 6 left over up on top. 1k cancels with one of these 3, and there's 2 left up on top. Both m's cancel with both m's. So the second fraction will be a minus. You'll have a 6 up on top, a k squared up on top, and nothing left on the bottom, right? So you don't need to put anything. You can put a 1 if you want, or you could just leave it 6k squared. And then the third fraction, you could cancel out 2 m's with 2 of these, and you'll have 1 left up on top, and you can't do anything else. So your third part would be 9. Whoa, why did I put a 3? I meant to say 9. 9m over 2k. And that would be your final answer for this problem. Okay, now we also did some long division problems on this worksheet. Like number 18, that one was a long division problem, because whenever you have negative exponents, you're supposed to grab it and move it to the other side. So in reality, you have that trinomial over 2y plus 3. Thank you. And then it becomes a long division problem, right? But instead of making it a long division, you could use synthetic. Now, the reason why I didn't show you synthetic before is because it's essential that you learn long division first. Now, on our notes from today from the board, it says, to use synthetic division, set your divisor equal to 0 and solve. And then place that value inside the box, right? And then write all the other coefficients of the other terms, including the zeros for the missing terms over here. So let's start by setting our divisor. In this case, the divisor is 2y plus 3, setting that equal to 0 and solving. So if I did do that on the side, 2y plus 3 equals 0, and I solved it, I want to subtract 3, I'll have 2y equals negative 3, which means that our y value is actually going to be negative 3/2. Yay? You guys understand that? Okay, now unfortunately, it's not going to look as nice as the other synthetic problem that we just did, but we know that this guy is what belongs inside the box. So when I go back over here, I want to put the negative 3/2 inside the box. And the coefficients over here, what are the coefficients over here? 6, negative 5, and negative 15. So 6, negative 5, and negative 15. And we put this division bar down there. Or not division bar. Call it an addition or subtraction bar. And as you go down, you just add. So there's nothing here to add. So 6 plus nothing is 6. And then you'd have to multiply negative 3/2 times 6. All right? Negative 3/2 times 6. That's like saying 3 times 6 is 18, but divided by 2. Right? So what is that? -9, correct? So we have a -9 up here. And then, as we go down, -5 and -9, what do we get? -14. Keep in mind that as you go up, you multiply. As you go down, you combine. Okay? So -3/2 times 6 was -9. And then -5 and -9 is -14. And then we're going to go -3/2 times -14. Now you could do this work on the side if you're getting a little confused. Let's go -3/2 times -14. Well, I know my answer is going to be positive. I'm going to put 14 over 1. And I could actually cancel the 2 with the 14 and get a 7. So I'm really going to get positive 21. So when I multiply -3/2 times -14, I'm going to get a positive 21. And of course, you have this line right here because whatever's left over is your remainder. So if I combine -15 and 21, that gives me a positive 6. And that's my remainder. So how am I going to write this answer? Well, you have to start by recognizing that you had a y squared divided by a y to start with. So your answer is going to have a y. So this 6 has a y on it. And then you have your constant value -14. And then you have a positive 6, so you're going to put a plus. And you're going to put 6 over the original divisor. And the original divisor is right here, 2y plus 3. Now that's as hard as it gets. Why? Because you're dealing with fractions. I don't know, if you don't like to deal with fractions, you might want to do long division. I still think it's easier to do synthetic with fractions. Yeah? Which other one would you guys like to see from this worksheet, or should we jump to today's worksheet? Yeah? Or do you guys want to do another one with the fraction? Like number 19 maybe? Or number 20? Or should we jump? Which one? 17. 17. Okay, that's from the other worksheet, right? Yeah. So let me jump to the other worksheet. This is the worksheet that I gave you today, the part B. So, you guys want to try 17, you say? Yeah. And we are going to use synthetic. So, this is just a fancy way of saying this polynomial divided by x plus 2. Remember, the -1 power is really going to make this whole thing go underneath. So it becomes a division problem with the x plus 2 down here. Right? Now you could do long division, but that's going to take twice, maybe 3 times as long as synthetic division. So let's do synthetic division. What goes inside the box? -2, that's right. If we were to set this equal to 0 and solve, we're going to get -2, so -2 goes inside the box. Now, listen to what I'm saying here. You need the coefficients of each and every power from the highest down to the smallest, and then your constant at the very end, but you need to represent every single term. So what's the first coefficient? 1. Whoa. 1. What's the second coefficient? -3. And what's the next coefficient? 0. Good job. Right? And the next one? 5. And the next one? -6. Perfect. Okay, so once again, see, the first coefficient was 1 because there's a 1 in front of the x to the 4th. What's in front of the x to the 3rd? A -3. What's in front of the x squared? Hey, there is no x squared. That's why I have a 0 right there, because there is no x squared. You have to represent every single term. Now, even if you were doing long division, you would still have to put a 0 there. Make sense? Okay, so this is the setup, and now it's just a question of understanding how it works. It's 1 that comes down, so you're going to have 1. Because as you go down, you combine. All right? And as you go this way, you multiply. So -2 times 1, that's -2. As you go down, you combine. -3 plus -2, that's -5. And as you go this way, -2 times -5, you multiply. And we get what? 10. And as you go down, you combine. 0 plus 10? 10. And as you go this way, you multiply negative 2 times 10. And as you go down, you combine negative 5 and negative 20. 5 and negative 20. Negative 15. And last but not least, negative 2 times negative 15. Positive 30. And let's not forget that line at the very end, because that tells us that that last one is our remainder. When we combine that, we really do get 24. Yay? So our answer is going to be, you're going to start with 1, but 1x to the what? 1x to the third power. Because the original had a 4, so x to the fourth divided by x is going to be x to the third. So let me write my answer here. It's going to be 1x to the fourth. You don't even need third. Whoops. 1x to the third. I keep making that mistake. Sorry. Minus 5x squared plus 10x minus 15. Now, because that's a plus 24, I'm going to put plus the remainder 24 over the original divisor, which is x plus 2. And this is it, guys. Way easier, way faster than long division. How about number 10? No, how about number 16? That one looks like fun. Yeah, 16. Let's do 16. So, ladies and gentlemen, if you wanted to divide with synthetic division, what goes inside the box? Negative 1 goes inside the box. Now let's talk about all the coefficients, starting with m to the fifth all the way down to the constant. All right? So what's the first coefficient? 3. Now, what's the next coefficient? 0, because m to the fourth is not there. So you have to say 0 m to the fourth. How about m to the third? Is it there? 0 also. How about m to the second? Is it there? 0 also. How about the next one? Positive 1, because there is an m. And how about the last one? Negative 1. Okay, so we have this 3 that comes down. And as you multiply negative 1 times 3, you get negative 3, correct? And as you combine 0 and negative 3, you're going to get negative 3. And as you multiply negative 1 times negative 3, what do we get up here? Positive 3. And as you combine 0 plus 3, what do we get? Plus 3. And as we multiply negative 1 times positive 3, what do we get? Negative 3. And as we combine 0 minus 3, what do we get? Negative 3. And as we multiply negative 1 times negative 3, what do we get? Positive 3. And as we combine 1 plus 3, what do we get? 4. Positive 4. And as we multiply negative 1 times 4, what do we get? Negative 4. And on this last one, we have a remainder of? Negative 5. So the remainder is negative 5 down here. So we actually have our answer. We just need to fill it in with the correct m values. So this first 3 is going to be m to the what? M to the fourth. That's right. And then the next one, minus 3, has to be m to the what? 3. And then the plus 3 has to be m to the second. And then minus 3 is next, which is just m. And then a plus 4, which is just 4. And then at the very end, you could put minus fraction, the 5 up on top, over the original divisor m plus 1 on the bottom. Okay, that means I need to end the video.